Hi guys, long time no see. And now today I'm going to talk to you guys about Taylor series and the MacLaurin series. I'm not sure if I pronounced that right, but well, we're not linguists, right? We're mathematicians. So, today we're going to focus on this topic. It's a series. So, first, what is a Taylor series? Well, a Taylor polynomial approximates the value of a function f(x) at the point x equal to, let's say, a. If the function and all its derivatives exist at x equal to a, then on the interval of conversion, the Taylor series, which is written like this. So, it's the sum of so this is like I'm sorry, this is the nth derivative of f(x), right? So here at x equal to a, we have the factorial of n, and we're going to multiply this with x minus a to the degree of n. So, this is a Taylor series, and this series, right, converges to f(x). Well, obviously at x equal to a, so yeah. So, okay, so this is like the definition of a Taylor series. It might get pretty confusing, and so here we have this conversion thing, and I think that I will account for that in future videos, but now we're going to jump into some examples in order to clear this up, because it looks quite confusing, doesn't it? Okay, so let's take example 1. So we're going to find the Taylor polynomial of degree 3 for f(x). So this is a function, and I'm going to pick this function. Okay, about the point x equal to 3. So here our a is 3. And now let's solve this problem. I'm gonna change the color of the brush. Okay, perfect. Okay, so here, first we're going to have to differentiate, right? Because that's what we have to do. I'm going to keep this part. I'm going to erase this. Okay, and then I'm going to solve it first. So first we have to differentiate. Okay, so let's say f prime x is equal to, so here we have f(x) equal to 1 over x plus 2, right? So f(x) prime is going to be equal to, so here 2, so this is how we're going to do it. Now here we're going to minus 2, and we're going to multiply with 1, because let's say we substituted x plus 2 for x, right? So we can just delete this, and what we have is this fraction. this is what we have. So this is the first derivative, right? So first order derivative, and now we're going to find the second order derivatives. So double prime, right? So you're gonna differentiate this, and we're gonna do like the same thing. So this is, so we're gonna put -2 here, and then we're gonna put -3 for the whole thing, and then this is what we have, right? I'm sorry, it's 2, right? And because it asks us to find the Taylor polynomial of degree 3, so we need to find the third derivative of fx2. So this is where it's going to end. Like we're literally gonna do the same thing. So here's a little space to draft it out, and here we say that let's put -3 multiplied with -2 is definitely going to. Oh, I'm sorry guys, we had a little bit of a mistake here. So let's say here with -2 multiplied with -1 is going to be 2. I'm very sorry for that. And now here we got -3, we'll multiply that 2 is -6, and then and we're going to rewrite this fraction. Okay, therefore, and now we're just going to apply that, right? So we have to find this. So because of degree 3, right? Oh, this is number 3. So this is our formula. I'm gonna write that here so that we're not going to forget it for the Taylor series. And now we're going to just apply this. So here we're gonna find at x equal to 3, right? So we're gonna put it 0, and now we're gonna obtain this is 5, right? So this is -1 over 25. This is 2 over 125, and this is -6 over 625. And now we're going to substitute those into this expression. I'm going to clean up our notes for a little bit. Here, I'm going to move that to here. Right? Okay, so now we're going to write this. So our Taylor series is going to be, so this is going to be equal to, first f0, so f0 is actually fx, right? So for n equal to 0, it's going to be fx over factorial of 0, which is definitely 1, right? And we have to multiply that with x minus 3, right? That is actually 1 here. So fx at x equal to 3 is 1 over 5, right? It's 1/5. I'm sorry, my voice. I'm actually a little bit sick right now, so my voice sounds a little bit weird and weak. A bit raspy. So now, let's take a look at fx. So here, f prime x. And now we're going to, add, f prime x, right? F prime 3, we're going to have to write 3 here. F prime 3 over, well, this is n equal to 1, right? So the factorial of 1 is definitely 1. Yeah. And x minus 3, well, 1. So this will give us minus x minus 3 over 25, right? And now we're going to do the same thing for our second and third terms, and what we'll have is going to be x minus 3, well, it's going to be square over right? Because like here we're going to have to divide that with the factor of 2. So the factor of 2 is actually 2 because we divide that. So we only left with 1 over 25 here. And then we're going to do the same thing for the third term. Well, it can get a little bit confusing for you guys, so I'm going to write that out. So it's going to be f 3 over 3, the factorial of 3, and it's going to look like this, right? And now we're going to substitute this for minus 6 or 625, and the factor of 3 is 1 multiplied with 2 multiplied with 3, and that's going to be 6. So here we basically have this. So this is the Taylor polynomial of degree 3 for fx equal to 1 over x plus 2. So I'm going to circle this. This is what we have to find. I'm sorry. Let's change the color of the brush. Here, this is what we have to find. So that's our first example. Okay, and now let's take a look at another example. So a function fx is approximated by the Taylor series 1 plus 2x minus 1 minus x minus 1 square plus x minus 1, well, let's to the power of 3. And now we're going to find f prime 1, and well, this is centered at x equal 1. And now we have to find f prime 1 and with the third order derivative of f1. Okay, so this is opposite to what we just did, right? So now we have the Taylor series, and we're going to have to find fx, and then in order to find, well, these two things. So basically, I'm going to do the same thing, but like in reverse. So now, let's take a look at well, the definition of a Taylor series. Oh gosh, I think that, well, the text is way too large. I need more space to write, so I'm going to, well, make it small like this. I hope that you guys can still see that clearly. And I've got to admit that my handwriting is not pretty nice. Okay, so let's take a look at the definition of a Taylor series. Oh, it's the sum of the nth derivative of a value a over the factorial of n, and it's going to be multiplied with x minus a to the power of n to the. So now we're gonna compare that with our series here. So now we're going to have, well, f1, right, over the factorial of 1, x minus 1. So this basically just that is equal to 1. So, oh, I'm sorry, this is actually 0, the factorial of 0. So for n equal to 0, which is the first value here, the first term here of our series, you see that, well, it's really clear that f1 equal to 1, right? And, well, we actually don't need to do all of that. But yeah, it's just like how you're going to find, like, based on that. Because we have to find, well, the first order and the third order derivative of fx, right? So we're going to look at these two values. Okay, so first, let's see. F prime 1 over, well, the factor of 1, x minus 1 to the power of 1. So it's basically, you can just write like this, is equal to 2 here. And now we're going to, well, it's pretty clear, right? And now we can find that, well, f prime 1 is definitely 2. So this value is 2. And we're going to basically do the same thing with this value as well. And here we're going to have the third order derivative of 1 over the factor of 3 is going to be x minus 1 to the power of 3. And it's going to be equal to this, right? So it's easy, right? So basically, the third order derivative of f1 is going to be, well, let's put that here, well, the factor of 3, and it's going to equal to 6. And that's how you guys solve this problem. Yeah, and it's basically, well, the opposite of what we did in the previous example. Now we have the Taylor series, and we use that series to determine, well, our function and its derivatives. Okay, so that's our second example. And now you're going to think that, how about MacLaurin series? Okay, so I'm going to talk about this real quick. So, a MacLaurin series is actually a Taylor series. The only difference, well, it's not actually a difference, it is a Taylor series, just centered at x equals 0. So basically, well, it's written like this, and 1, so it's going to be fn 0 over, well, the factorial of 0 is 1, so we don't need to write it here. And we're going to, well, just multiply it by x, right? X minus 0 to the power of n, so it's basically x to the power of n. And it's a little bit, you can see that it's simpler than, well, the formula of the Taylor series, right? So this is what we have. Okay, and now let's jump to the next example where we're going to discuss about this series. Okay, so we're gonna find the MacLaurin series to, polynomial. Well, it's a series, but it's endless. So now we're going to consider a polynomial of degree 4 that approximates fx equal to natural log 1 plus x. Okay, so now the first step is, because it's actually a Taylor series, so we're going to do just the same. So the first step is going to be differentiation. And now I'm going to find f prime of x. So f prime of x is pretty clear, right? 1 over 1 plus x. Well, if you guys struggle this part, I recommend you guys to, well, take a look at my previous video on differentiation. Okay, so back to the topic. I'm sorry, back to this example. Let's find the second order derivative, and we're going to, it's equal to x plus 1, this one, right? So it's pretty easy to do this, and you obtain this. So we're gonna do pretty much the same thing for the third order derivatives. So it's going to be 2 over x plus 1 square, and because we need to find the polynomial of degree 4, so we need to find up to the fourth order derivative of fx. So that's going to be, oops, I'm sorry, that's a silly mistake. X over x plus 1, 2. Okay, and now we're going to evaluate these at x equals 0 because, well, this is a MacLaurin series, right? Equals 0. So now here we have 1 over 1 plus 0 is 1, right? Minus 1 over 1, it's minus 1. And here 2 over 1 is 2, and minus 6 over 1 is minus 6. And this is what we have right now, right? Okay, and it's going to be very easy, right? Because let's remember the formula for the MacLaurin series. So the thing we need to find is, the polynomial of degree 4. So we're gonna, oh gosh, we're going to find well, up to 4. So n starts with 0, right? Of f n 0 multiplied with x to the power of n, right? And now for n equal to 0, then we're going to have f0. So for f0 is natural log of 1, right? So it's definitely going to be 0. Oh, I'm sorry. Yes, it's going to be equal to 0, and we need to multiply 0 by 0. And we're going to need to multiply with well, x to the power to the power 0. So it's going to be, well, I'm sorry, there's something wrong here. The thing is that these are, so you can see that that is equal to 0, so we don't need to write it in our equation. So here, and now let's take a look at n equal to 1. So that's going to be f prime 0, that's 1, right? 1 multiply with x to the power of 1. So we have, what we have is x, and now we're going to plus, right? Let's see. So we have minus 1 here over, well, obviously, oops, there's something really wrong here. I forgot, right? The factorial of n. That's like super important. Don't exclude that out, guys. Okay, and now that's actually, I'm sorry, because this is n equal to 2, right? So, and now we're gonna multiply with x squared, and basically what we have is this, because the factorial of 2 is 2, I'm gonna plus, and what we have here is 2 over the factorial of 3, which is 6, and I'm gonna multiply it with x to the power of 3, and now we're gonna plus our final term. That's going to be minus 6 x to the power of 4 over 4, the factorial of 4. That's going to be 24, right? So that's it, and that's how we obtain this equation, this series, right? So this is the MacLaurin polynomial of degree 4 that approximates this function right here, and that's how you find it. Okay, and now let's take a look at another example. Example number 4. And now we're going to find the Taylor series for the function fx. I'm just going to write Taylor series here real quick so that we know what we're dealing with. Equal to e to the power of minus x. About the point x equal to the natural log of 2. Okay, here. Don't freak out when you see these symbols. That's actually pretty easy because, well, and now we're going to differentiate. And this function is really special because, well, I'm gonna write some of the derivatives for you guys in order to see the pattern that's actually happening. So here we have, well, f prime x is going to equal to, easy, right? E to the power of minus x, and now we're going to find the derivative of minus x, and we have to add a minus sign before it. And now for well, the second order derivatives, it's minus 1 multiply with this one, right? The derivative of this one is going to be minus e over x is actually e to the power of minus x. And so here, you think that it's equal to fx, right? So, and when it's very easy to see that the third order derivative of fx is going to be f from x, right? So what we see is that there are only 2 values of the derivative. So here, let's say that if the nth derivative of x is equal to e to the power of minus x, if n is even. And well, on the other hand, is going to equal to minus this value if n is odd. So let's see. Well, and now we're going to put natural log 2 here. So this is what we have. I'm sorry, that looks a little bit hard to see. So it's definitely going to be, well, e to the power of minus natural log 2, right? So it's going to be obviously 2 to the power of minus 1, which is 1/2, right? And therefore, when n is odd, well, it's going to be equal to minus 1/2. And now let's write our Taylor series. So here, I'm gonna say 2 over n, the factorial of n, to the power of n, right? This is what we have, and it's going to equal to, let's say when n equal to 0, it's going to be fx. Well, here obviously it's even, right? So we 1/2 over the factor of 0, which is 1. I'm gonna actually write that in here. X minus natural log of 2 and to the power of 0, right? And let's see. Well, I changed my mind. I'm going to write that here so that you guys will see a pattern afterwards. And minus 1 over 2, right? To the factor of 1. Plus so are you guys able to see a pattern now? And we can easily see that this is an alternating series, right? So I'm going to rewrite the expression for this series, which is, well, because it's an alternating series, right? So it's going to be, well, for x equals to 0, you see that this one, I'm sorry, when n is equal to 0, you can see that it takes up the positive value. So here we have to write n or n plus 1, right? But in order for it to be positive, we're going to write n. So well, and now you can see that in the denominator there's 2 multiply with the factorial of n, right? And we're going to multiply it with x minus natural log of 2 to the power of n. So this is the Taylor series that we have to find. This is our answer. I hope that you guys get it. It's not that hard, right? And now let's take a look at another example. And now it's about the MacLaurin series. Okay, so for the function of x equal to x multiplied with e to the power of x, right? Okay, for this, well, first of all, we need to write the formula of it, right? So this is the formula of the MacLaurin series, right? And now we're going to differentiate fx. Okay, so do you guys remember the product rule? And now we have to do that, to use that. Okay, here fx prime is going to be x plus this, right? And now for the second order derivative, so the derivative of this is e to the power of x. And here, it's actually the same. This part is actually the same as fx, right? So basically, it's going to be 2 e to the power of x plus x to the power of x. And here it's going, so for the next derivative, well, we can just put that here, and plus this is going to be e to the power of x plus x e to the power of x. And what do we have? Going to be 3 e to the power of x plus x multiplied with e to the power of x. So you can see the pattern now, and so we can turn that into one simple expression. We can encapsulate all of that as the nth order derivative of fx is going to be n multiply with e to the power of x plus x e to the power of x, right? It's just that easy. So, okay, and now we're going to evaluate it at, because you see it's a MacLaurin series, right? So we're going to deal with x equal to 0. So here, x equals 0, then this one, we can cross it out, and basically, e to the power of 0 is going to be 1, so what we have left is n. So now we can just put that in here, and so the MacLaurin series is expressed like this, n, right, multiply with x to the power of n. And now, the factor of n, well, divided by n is going to be the factorial of n minus 1, right? So this is what we have to find. Okay, great. Now, next, let's take a look at. So now, after, well, as you can see, I showed you guys lots of examples of the Taylor series and MacLaurin series, and also explained to you guys what are those series. I hope that you guys get the hang of it, and it's the end of this video. Thank you for watching, and remember to subscribe to my channel for more videos like this. Bye bye.